Chapter 7.3, more multiplication properties of exponents. So in 7.2, we noticed that if you have a base, like a squared times a cubed, you add the exponents, a to the 2, let's make that a 3, to the 2 plus 3, or a to the 5th. So today we're going to talk about what you do when you are going to actually raise that base to a power instead of multiplying them together. So if I have x to the 5th power, all of that squared, that's the same as x to the 5th times x to the 5th. Well, x to the 5 plus 5, or 5 times 2, equals x to the 10th. So notice here I have 5 times 2. I have exponents of 5 and 2. So when you are raising a base to a power, you are going to multiply and find the product of the exponents. So let's take a look. What is the simplified form of n to the 4th power to the 7th power? So n to the 4th raised to the 7th. I'm going to multiply those exponents. So equals n to the 4 times 7, or n to the 28th power. Example 2, what is the simplified form of x to the 2/3? X to the 2/3 power, all raised to the 1/2 power. Again, I'm going to multiply my exponents. So x to the 2/3 times 1/2. I'm going to cross cancel these and get x to the 1/3 power. Okay, so you're simply multiplying your exponents together. All right, example 2. I want you to pay careful attention to your order of operations on this. Okay, parentheses first, then exponents, then you multiply and divide, and then you add and subtract. So what is the simplified form of y cubed times y to the 5/2 raised to the -2? So you are not multiplying y to the 3rd and y to the 5/2 first. You're going to do the exponents first. So the y cubed is going to stay put, and I'm going to multiply that times y to the 5/2 times -2 over 1. Y cubed times y to the -10 divided by 2 to the -5th power. Now I'm going to go ahead and add y to the 3 plus -5 equals y to the -2 power, but I can't leave it as a -2. I need to take it as 1 over y squared. Okay, so keep in mind all of those things that we have been doing and building since lesson 1. Okay, so the simplified form of y cubed times y to the 5/2 raised to the -2nd power is 1 over y squared. All right, example 3. You can use repeated multiplication to simplify an expression like 4m to the 1/2 to the 3rd. So 4m to the 1/2 raised to the 3rd is taking this whole expression and multiplying it 3 times, which then if I pull out the 4 from each one, I have 4 times 4 times 4, and m to the 1/2 times m to the 1/2 times m to the 1/2. So let's take a look about how to find the area of this square. So this is a square with a side length of 5x cubed. So 5x cubed is going to get squared. 5x cubed times 5x cubed. So that's the same as saying 5x cubed times 5x cubed. Pull the exponents. 5 times 5 times x cubed times x cubed. 5 times 5 is 25. X cubed plus times x cubed is x to the 3 plus 3, or x to the 6th. So the area of the square is 25 x to the 6th units squared. All right, example 4. What is the simplified form of n to the 1/2 to the 10th times 4mn to the -2/3 to the 3rd? Okay, so there's kind of a lot going on here. So the first thing we need to do is to break this into its pieces and deal with the exponents first. So n to the 1/2 raised to the 10th is n to the 1/2 times 10, or n to the 5th. Okay? 4mn to the -2/3, all raised to the 3rd, means 4 to the 3rd, m to the 3rd, and n to the -2/3 to the 3rd. So bring everything down. N to the 5th. 4 to the 3rd is 4 times 4 is 16 times 4 is 64. M to the 3rd. Now n to the -2/3 times 3. -2/3 times 3. If I cross cancel, we're going to get -2. Okay, and now I'm going to rearrange and simplify. So 64, because my coefficient always goes first. M cubed, because it's first alphabetically. And then n to the 5 minus 2 power. We need to simplify this because I have n to the 5th and n to the -2. So I'm going to add these exponents. So I'm left with 64 m cubed n cubed. And that is as simplified as we can go. Okay, so now we're going to use a scientific notation problem. The expression 1/2 mv squared gives the kinetic energy in joules of an object with a mass of m kilograms traveling at a speed of v meters per second. What is the kinetic energy of an experimental unmanned jet with a mass of 1.3 times 10 to the 3rd kilograms traveling at a speed of about 3.1 times 10 to the 3rd meters per second? So, our formula, okay, the kinetic energy is equal to 1/2 the mass times the velocity squared. So my mass, 1.3 times 10 to the 3rd kilograms. My velocity, 3.1 times 10 to the 3rd meters per second. So let's start filling in numbers. I have 1/2 times my mass, 1.3 times 10 to the 3rd, times my velocity, 3.1 times 10 to the third, but my velocity is squared. So 1/2 times 1.3 times 10 to the third times 3.1 squared times 10 to the 6th, because 2 times 3 is 6. I'm raising a power to a power. So let's rearrange these. So I should have 1/2, 1/3, and 3.1 squared grouped together, and 10 to the third and 10 to the 6th grouped together. So 1/2 times 1.3 times 3.1 squared times 10 to the 6th plus 3. So if I go ahead and do that math, I get 6.2465 times 10 to the 9th joules. So this is the kinetic energy for the aircraft of this weight or this mass and moving that fast. Okay, a lot of pieces. Take it step by step, use each other's resources, get those got-its done, and if you have questions, I'll answer them the next time I see you.